So in this game, we have 3 strategies for player 1, 3 strategies for player 2, and I was writing the payoffs here. So we will be using the best response function to solve this game and see if this game has a Nash or not. And in the meanwhile, we'll also see whether the Nash is a strict Nash or not. So let's see it for player 1. Let's talk about the best response of player 1. If player 2 is playing L, the best response of player 1, so we are in the first column here. So you can see that the best response here is 2. Is to play M because that's giving the highest payoff. So if you look at Osborne, it's using a star here. Later on, we'll be doing Snyder and Nicholson. They are doing the underlining method. So you can do whatever you are comfortable with. I am underlining here. So you can put a star also like here, the way Osborne is doing. Okay, if player 2 has played C, the best response of player 1 is to play 2. So I'm again underlining this, is to play T. So that will give him a payoff of 2. If third player is playing R, so we are in the last column here. So best response of player 1. Now look carefully here. T is giving a payoff of 1 to player 1. B is also giving a payoff of 1 here. So I'll be underlining this also and this also. So if you look carefully, if I write here best response of player 1, if player 2 is playing R, so it will be 2 actions, which is T and B. So best response function need not have a unique action. It can have more than one, and it can, if it's a continuum action profile, it can have a continuum infinite number of best responses also. Alright, let's do it for player 2 now. If player 1 has played T, the best response of player 2, so that means we are in the first row here. The best response for player 2 is to play L because L is giving the highest payoff here. If player 1 has played M, the best response for player 2 is either player 2 can play L or C. Again here, if player 2 has played M, if player 1 has played M, player 2 can either play 1 or player 2 can play C. Again here, the best response of player, if I can just do that modification here. Okay, let's write it again. Best response of player 2, given the fact that player 1 has played M, is 2 strategies again here. So player 2 can play either L or he can play C also. He will be indifferent between the two. So if if player 1 has played B, their best response of player 2 would be to play 2 here. So we need to find Nash equilibrium here. So that particular block will be a Nash equilibrium where payoffs of both the players are underlined. That means where both the players are playing their best response action. So if you look here, this particular block here, where player 1 has played M, player 2 has played L is a Nash. And then here you can see where else you have both the underlines here. Here again, player 1 and 2 are both playing their best responses. So as per the definition of Nash using the best response function, if both the players are playing their best response, then that particular state is a steady state or a Nash equilibrium. So this particular game has 2 Nash, this and this. But if you look carefully, this Nash is not a strict Nash because player 2 here is indifferent between strategy L and C. And likewise, this Nash is also not a strict Nash because player 1 is indifferent between strategy T and B. So this is a game which has, first of all, 2 Nash. Second, none of the Nash are strict Nash. They both are non-strict Nash. And we've used best response functions here to find out our Nash equilibrium. And from now on, whichever game you do, please try to use the best response function only to find the Nash, because that's the most easiest and that's a way in which you are less likely to make any mistakes. So in this particular game, we've got 2 Nash. We have found that using the best response function. Thank you.